Well, hi and welcome to my shop, and thanks so much for joining me, spending some of your time with me. Today is January 2nd, and honestly, when I came in here about 15 minutes ago, I just had no clue what it is I'm going to try to do to this radio. So I spent the last 15 minutes just pondering the situation. Let me just recap very briefly where I think I am. And that is, I think yesterday I discovered that the first IF stage, if I can call it that, this area here, is not performing properly. I tested the tube. Tube seems to be fine. That's like the third time this tube has been tested. It's fine. But when I feed a signal in of an appropriate amount into the grid as instructed by the table here, I do not get nearly the output from the speaker that I would expect. On the other hand, when I inject the signal here into this tube and onwards, I do get pretty much what is expected according to this table. So it sure seems like things just break down between here and here. But what to do about that, and what to test next, what to be suspicious of, I don't know. Except to say, well, obviously there's a defect right in the transformer here, which I don't want to say because that's kind of a bit of a death knell for this radio. Now, this radio's not dead. It's just not feeling well. But maybe that's the way it's going to be in the end, unless I can sort something out. So I got curious about these two resistors that are in the ADC circuit. And the reason is I've been curious about this one for a while, so I thought I'd take a closer look at it. Here on the schematic it says 2.2 megohms. This one says 1 megohm. When I measure these resistors as best I can, which I'm going to repeat in a moment, this one comes out 990,000 ohms. It comes out to be a megohm. The color bands on it indicate a megohm. That's a megohm. This one, no. This one doesn't come out at 2.2. The bands don't suggest 2.2. It measures around 800, and sometimes the measurements are quite wonky. So we're going to really focus in on this resistor. Now, I just finished verifying that the resistor I think is this one. We're going to start with that right away. Am I really on this resistor? So if we trace back, we see it's connected to the top of the volume control. Okay, there's no question where the top of the volume control is, and there's a wire that runs from the top of the volume control to this terminal on this transformer. Okay, these things are visible, but I'm just going to go over them again here. We'll take a look. Maybe I should employ the close-up camera. I'm sure you can see enough from this. So the resistor which measures appropriately is this one right here. Brown, black, green. 1 megohm. Right here, and that's what it measures at. The other resistor, which is essentially in series with this one, you could think of it that way, has to be on this terminal. There's only one resistor on this terminal, and that's this one, hidden back here, this little guy here. Let's put a little extra light on it. When I look at the bands, what I see is brown, silver, green. So green, can you have a 10 meg resistor with a green third band? The other side of this resistor, which is hard to trace, comes down here to this terminal. This terminal is right on one of the two IFs. Just be a little more specific and look at the diagram to be sure. So that's on IF number 2. IF number 2. Tricky to spot. It's right here. 1 is here. Absolutely correct. This is number 2. And if I look at the schematic, bring that back. See 1 and 2, here's 2, here's the resistor I'm tracing, and it's connected right to 2. From 2 here, from this terminal, same terminal, there's a wire that goes to the top of a volume control. Look at the volume control here. The top is back here. Oop. Take these out of here. So that's the top of the volume control. Or have I got it all backwards? No, I can't. See, there's a black wire here coming to this terminal from here, and this is the B minus bus. It's coming along here, tied to here, tied to the here. There's no question. This is the bottom, if you like. This is the input side. You can put it that way. And there's a wire. Wire comes right over to this terminal, which is where that resistor goes. So there's no question this is the right resistor. What to do about the colors on it and the value? Let's look more closely at the colors on it. Come on, camera. Sorry about that. So it's silver, green, silver, no, brown, silver, green. Well, like, it should be red, red, green. Red, red, green would be 2.2. Brown, silver. 1 silver? Or that one is discolored? Okay, I'm going to put the ohm meter on that. Thank you for going out of focus just like I would plan it. So I'm checking the 0 on my meter because of wonky readings. Expecting it to be 2.2, so I've got it on a 20 megohm scale. I'm going to go right on the wire to the resistor and then up on this terminal. Every time I do this, I get a different reading. .5. 2.2 there for a brief moment. Why is this so unstable? Before I was getting 800. 800. Is it the resistor shot? Is it a resistor? The contacts failing in it? Let me give it a poke. Oh, that seemed to do a thing. 2.6 now. Well, that's one of the reasons why I like to repeat these things over and over. I was actually clipping it here. Now we're getting a sensible reading. Let's check the 0 again. Well, that's how it goes. Oh. Well, we're getting 2.5. 2.6. Should be 2.2. Well, you know, I've got no other angle on this, so I'm going to change that with a appropriate 2.2 megohm resistor as called for on the schematic. Can't imagine that's going to fix this thing. But maybe there's something going on. It heats up, it behaves differently. I doubt it. I don't think there's much current going through it. Shouldn't be really any current going through it. Okay, I'm going to change that resistor. It's a long shot, but what have I got? Okay, I've got the resistor out. Let's take a closer look at it. It should be red, red, green. Well, I don't know. It certainly doesn't look red, red at all, does it? Okay, And let's put this back on the ohm meter here. Now that it's out. So it's been a very mild winter here in Aurelia. Today's a cold day. It's about -5 outside. Oh, look at that. There's nothing wrong with this resistor. Yeah, okay. Yeah, has not been a very bad winter for us. Hardly any snow really has fallen here relative to what should fall. And there's been rain and some warm weather, so we're into January now. Man, where's the winter weather? Okay, I'm going to stick a new resistor in there. Fat chance on it helping out. Maybe while I put this resistor in, we can talk a little bit about the scourge, the COVID scourge. Here in Canada, it is blasting off with dramatically increasing numbers of infected people. Governments are taking fairly desperate actions now, a little similar to what you see in the States, changing the length of time that you have to hide away once you have a positive test, from down to 5 days. They're just following what the Americans are doing, basically. And I'm not saying that that's unwise. It's an act of desperation, because I believe the governments can see what's coming in the next couple of weeks. The expectation is so many people are going to be sick, vaccinated or not. They're going to be required to hide in their homes and stay out of circulation. There won't be enough people in circulation to keep the wheels turning. And Canada's a very large country, of course, so there's a regional aspect to everything. What's happening in one area is not necessarily happening in another area, or happening in the same way or at the same rate. So there's a mixed bag of directions across Canada. People are complaining about whatever the decision is by any government, whether it's turn left or turn right. There's people who are ready to say the opposite. It's a very difficult situation. I'm sure it's very similar in many, many other countries. It's a little too cold here to, really go out and demonstrate, so there's no demonstrations of any great significance. There are some. Should I even bother? I shouldn't even bother with that. So we do have some anti-vaxxers and people like that. I think one of the silliest situations is the premier of my province has a daughter who's an anti-vaxxer and a conspiracy person. In my view, that's my opinion. Okay, how I see it. And poor premier has to be standing on the soapbox telling us all to take our vaccines, while his own family's members are telling us the opposite. It's a pretty strange situation. Surprisingly, the media has not really gone to town on that. It's bad enough that the premier has had people outside his home, which I don't agree necessarily with what the government's doing, not necessarily, but I don't think there's ever a time where you should be, really going after politicians in their homes. The big problem with that, in my view, is making it uncomfortable to be a politician. Means all kinds of quality people will not put their hand up and say, I'll give it a try. The quality people will be saying, I can do something else with my life. Why would I want to do that if I'm going to end up with kooky people parading around the street in front of my house claiming kooky stuff? I don't want to be part of that. I think it's probably a worldwide type problem. Just who are you attracting to become your politicians? You want You want well-educated people who understand the law and administration and large organizations and even have direct experience with maybe lower levels of government and stuff like that. That's who you want. But it seems like what we're getting in our country, at least in the case here in my province, is rich guy decided, hey, I'd like to be the premier. So, hey, presto, he's the premier. And this doesn't necessarily mean that people who have a lot of money are of some better or worse quality from others. It's not necessarily the case. But sometimes the credentials that they step forward with are credentials that mean nothing in government. So, so look, I'm a businessman. I'm not even sure what that means. Business person. What's that really mean? Spending my life trying to put money in my pocket all the time. I don't know. What is that? I use that as a qualification to become a politician? It doesn't make sense to me at all. I'm just fixing up this connection here, which is okay, but I think it would be okayer if I stuck a little more solder on it. A little hard to see in the camera. Blink. Yeah, that's a little better. So that's the situation here in Canada. Expectation is the peak is going to come through sometime in January. No one knows for sure, of course. And so our hospitals are pretty full. In some places they're too full. When I look back on the charts and I see what it was that happened the very, very first wave, it's a pittance compared to what's happening now. It's quite stunning. The one number that's dramatically different is the number of people who are dying. Lots of people getting sick, not a lot of people dying. The normal death rate in Canada on a daily basis is 750. Roughly 750 people die for all kinds of reasons every day in Canada. Population here is about a little over 35 million. So it's instead of 750 with the COVID deaths added in, it's 765, 770. So from that perspective, not a lot of people falling from this illness right now. It was different last year, but right now, not many. And I think it's all about the vaccinations. As much as people are still getting ill, the illness is not putting them in the hospital. I think this is true all over the world. Our vaccination rate here is up around 85% of people over the age of 5. It's something like that. Again, it's regional, varies a little bit as you go across the country. But generally speaking, we're in the case of my own family, all of us are triple vaccinated now. Okay, is it even worth testing this radio? Man alive, I didn't really do anything there that should make any difference to the radio. Now what happens if I read that resistance now? I was getting kind of weird readings before. When you read stuff in circuit, you can get some weird stuff. Weird stuff, look at that. So obviously it's in parallel with something. What would cause that? I checked this resistor before I put it in, by the way. It's exactly 2.2 megohms. So how do you read across this resistor? First of all, this leg goes nowhere. This leg, well, because of this capacitor, it goes nowhere. What if that's again, that capacitor, it's the second time I pointed at it and wondered about it. And this way is through a capacitor down to the B minus. So, unless these capacitors are terribly leaky. This one can't be, it's new. The only other one is this one. It does find its way to a ground. I could take some kind of resistance measurement from here to the chassis. And I should see, it should be well over 1,000,000 ohms. It should be like open circuit practically. So I think to get to the chassis, to go through this resistor, can't get there this way. You come through this one, this is a 500,000. Then you get not to the chassis but to the B minus. Ooh, chassis and B minus. Chassis and B minus. So if you go this way, you end up on the chassis. Well, that's really ending up nowhere, because the chassis only gets back to the B minus through a capacitor. So from a DC test with an ohmmeter, there should be nothing interfering with the measurement of certainly this resistor, which I did measure at 1,000,000. How come this one? Is that an indication right there that I'm testing this and not getting 2.2? Just go over that again. On this side of the resistor, can't get anywhere this way. Just went through this. You can't get anywhere this way. This way you can get to B minus, but because you can't get anywhere going this way, you should be able to read that resistor without any problem. You could come through this resistor, the volume control, sneak out the back and head down this way to, well, you're just going over to another open circuit on the phono jack. Well, I'm going to put the ohmmeter on here and I'm going to turn the volume control up and down. Just go on a little fishing expedition here. Okay, wait a minute. There's a bit of a wire tail sticking out up here. I wasn't touching anything. Okay, back on. 2.2 million. Well, maybe we're encountering bad capacitors here. Where, yeah, it's still reading 300K, 400K. I've convinced myself it can't read anything other than 2.2. Okay, I was going to turn the volume control. Difference. I come over and I connect onto the volume control. The same reading. Should be the same reading. It's just a wire running from where I was hooked up to where I am now. Okay, so if I go on the volume control, I should see a difference when I turn this. 0. How do we get 0? How do we get 0? I've still got this resistor in between these leads. And this side doesn't go anywhere. So, how do you get a 0? Yeah, it's a real 0. How do you get a 0 there? How do you get a 0 there? So I had one clip lead here. This goes nowhere, DC wise. And the other clip I just moved basically from this point to this point. That's really what I did. That didn't change anything. Then I moved on to this terminal right here. When I turn the volume one direction, we get the resistance. When I turn it the other way, we get a 0. How do you get a 0 out of this? From a DC point of view, this is going nowhere. What's happening? Okay, so the resistance of the volume control itself is supposed to be 500. 500,000 ohms. Might depend on where this is turned. So we're getting 300. Oh, what did we get there? Supposed to be 500. So because this other alternate parallel path is making it look less, is it really the case that on the far side of this resistor there is no connection back to B minus? Wait a minute. This is B minus. Oh my god, I've connected this resistor to the wrong spot. Yeah. Yeah, that resistor I put in, I put in wrong. Yeah, good thing I didn't turn the radio on. Got it here, and it's not supposed to be here, it's supposed to be over here. That's why it had a cover on it. The original one. And then when I put the new one in, I thought, well, what's a cover there for? I should have thought a little harder about that. Okay, saved myself from making a mistake. But now I've got to sort this out. Ho. Okay. Yes, a large portion of my troubleshooting is hunting down my own mistakes. That's really the truth of it. Shame on me. Okay, so I fixed the wiring of that resistor, and what you're looking at right now is a resistance reading between the B minus bus and the chassis. And shouldn't that just be open circuit there? That's my question. And also, what's with this weird cycling thing, which I see this periodically when I'm doing tests. Ohm readings. And I have no idea why my meter's doing that. Now it's going to settle down. 4 megohms. pick up a different B minus point. Same deal. 3 megohms. 4 megohms. I have no idea what I'm doing. What would you expect with a reading like this? Give me a stick. Between the B minus and the chassis. The only official connection between B minus and the chassis is this capacitor. Ooh, there's another one here. I've replaced these. Is it possible that it's B minus is tied through all these? Missing bulb. If the plug is out, that's the end of the road. But the plug is not out. The plug is in right now. But that doesn't go anywhere. I have switches switched off, and they're double pole switches. It shouldn't be going anywhere. Should not be going anywhere. Let's put this back on between the chassis and B minus. Makes any difference. Tuning the radio. Oh my god, that's how desperate I am here. Very desperate. Let me get to that switch spot. Nothing. Why do we get 4 million ohms? I basically have my ohm meter across this. So go this way, capacitor. Here, open. Here, open. If it goes into a tube, it's open. Open. Okay, so this is a little more tricky now. Come up through here, go through 500,000, go through another couple million, to wrap around 3 million now. Go along through here, that's around 4 million. There we are, that's what it is. But wait, this capacitor's here. This capacitor I'm going to go after this capacitor next. A 47 picofarad capacitor. 47 picofarad capacitor is located off of pin 7 of the 12BE6. This is the 12BE6 here. Pin 7's right here. You can see a lead disappearing through a hole, showing up in about the most awkward place in this radio. That's the guy there. Okay, so how can I come to grips with that capacitor without doing? I can disconnect this one lead. I can disconnect it and I can reconnect it later if I want. That's what I think I have to do. I have to disconnect that lead. What am I overlooking here? I don't think anything. Okay, I'm going to try to get that capacitor off of there. I'm reticent to jump in and change it. It's awkward. If it wasn't awkward, I would do it. It's awkward, so some kind of more evidence is needed. Let's see if I can just get the wire out of there. I'm trying to preserve the wire here. Preserve my sanity. Maybe I should concentrate on that. I don't think I'm getting it. There we go. Almost got it. It's loose. Okay, I'm breaking a rule here because I'm holding that soldering iron without Actually, I should not be holding it. Let me put it away. There we go. Okay, capacitor is off. What does that reading say now? Looks very same. Okay, what am I not getting? We have that capacitor disconnected. Test it. Let's see what the test reveals. If I can get on the other side of it. I'm just going to unplug this here. Okay. Well, that's what that says. It's definitely on the capacitor. I don't know if I can get all the way in there. Short leads I'm using. On the lead. Well, that's not a very good indication. That's two indicators that there's trouble with this capacitor. Let me leave that in there. It's a very small capacitor. Put a capacitor checker on it and see what happens. Well, I won't be able to read the value because the 47 picofarads, the leads I'm going to use are won't have that much. Let's try it. So I'm going to put a high voltage test on this capacitor. Let me just make absolutely sure it's connected the way I think it is. A little flashlight. Okay, I can see the connection right on the lead of the capacitor. Okay, let's go over to the capacitor checker here. Little capacitor like this should show no leakage, and the eye should respond very quickly when I hit the switch here. Okay, we're ready. It stayed closed. It's a bad capacitor. How come that reading didn't change when I cut it away, though? That's a little bit surprising. There's some more of those in here. That guy's bad. I sort of reasoned out before that if that capacitor's bad, it would basically, you know, from an RF point of view, it's kind of doing what I'm about to say anyway. But you know, it would drag down the AVC voltage here. Drag down the AVC voltage. That might cause problems with the signal coming from the antenna. Although you'd think a short would allow more signal to reach the grid there. Okay, we got to replace it. See what happens. Okay, before I put in a capacitor, let's test the one. This says 47 picofarads on it. There's the result. .48 this time. It's even better. Okay. I'll stick this guy in place of the one that's in there. Now it raises a question about all the other similar capacitors that are in 1, 2, 3. Yeah. Okay. This is going to be very awkward. And we'll work away at that. Well, it looks like the only way I can really get in there and do what I have to do is to clear a path. The only thing I can do is loosen this off and kind of swing it a little bit out of the way, which I don't like doing, but I have no other option. I've already checked it's held in. It's not held in with nuts. It's got threaded. It goes into a threaded. I can tell it's a Canadian radio from the square head screws that are in here. Now the wires are not very long here, so this speaker's not going to have a lot of play in it. Hopefully I can get enough clearance. I'm not going to introduce more trouble. Okay, I think I can get my hand up in there now. Okay. Let me flip it right over. There he is. Yeah, there's a tube missing. There's a tube missing. When I tested the 12BE6, I thought I started. No, you know what? I couldn't get it back in there for the same reason, and then I just went off and who knows what. Somewhere there's that tube. Okay, so change the capacitor, stick the tube in. Give it a try. Time for lunch though. Okay, let's take a look and see. Bend it away from the tube. There we go. That's one end. Okay, let's give the capacitor a last chance. Huh. So I think it's the terrible leak through here that must be putting it in the category of a damaged part. Very good. New one's in, soldered in. Make sure it's not shorting to the chassis. We're going to try this radio out. Just see if by some chance it's full of life now. Is that somebody calling me? Somebody calling my name there? Anybody at the door? No. There's nobody there. There actually is somebody there. Okay. I'm trying to ignore him. I'm talking about my cat. Oh, we got all tangled up here. Okay, I'm a little excited by this test. We can just leave this on here. Let's just untangle things a little bit. Oh, someone is calling for me. Peanut, can you wait just a minute? Okay, switch is on, but the volume's down. Plug goes in. Watch those dim bulbs right by the Canadian flag there. Here we go. Perfect. And I did put in the tube, in case you didn't notice, while I had the speaker out. Come on, little radio, do your thing. Lots of volume. Lots of volume. That was it. Oh, I was going to put the camera on my cat, but as soon as he saw me move, he thought I was leaving. He made a run for it. He didn't go very far. No distortion. Much better than expected. No, actually, that's what I expected. Thumbs up. Got the bad guy out of there. Radio's operating. So tomorrow, I will do the alignment on it and finish up. And we're on to the next one. Oh man, thumbs up. Thank you very much for watching. See you tomorrow.